I remember when I was a kid, I created a super flat Minecraft world using the Redstone Ready preset. I'm not sure what really makes this Redstone Ready besides removing the slimes and structures, but here's what it looks like. I tried to find the real world to film this video in, but as much as I practice data hoarding nowadays, I've lost a lot of my old Minecraft worlds, servers, and even friends. One thing I haven't lost is the memories. Aside from the random beacons providing random effects, I remember many command blocks strewn across the entire map that spawned weird items and granted weird potion effects. My favorites were the levitation effects. In survival gameplay, levitation is obtained from getting hit by the bullet of a shulker, causing you to slowly lift into the air. In the current era of Minecraft, newly added potion effects rarely utilize the full range of 256 levels available for each potion, but many old potions often do support these extra levels obtainable only through the effect command. While these generally work fine in newer versions of the game, older versions like Minecraft 1.16 can produce some very unusual issues. For levitation, each additional level is supposed to have the player rise faster. For mobs, this works perfectly fine, but for players, something weird happens at potency 128. Instead of rising into the air, the player is instead stuck to the ground, rapidly rocketing downward if they attempt to jump. This behavior continues for the next 120 levels, but as we approach the maximum potency of 255, the falling speed appears to become lesser. In fact, at 254, the player is starting to become lightweight and can now jump up over a full block and a half. Finally, at the maximum 255, the player appears to defy gravity as they can no longer jump nor fall, only glide horizontally. So let's get to the bottom of this. Before diving into the code, my guess was the game was converting a large number type to a smaller one, specifically a signed 8-bit byte, causing an integer overflow similar to the one I explained in the previous video. I knew old Minecraft versions often tried to use smaller number types to reduce file sizes, among other minor benefits, so it seemed likely to be happening here too. However, my first glance at the code couldn't spot any such issues possibly occurring. From what I could tell, the server should have been fully aware of the correct potion level. And right then is when it clicked for me. The server was fully aware, but the client was not. Whenever you play Minecraft, whether it's on someone else's server or single-player world, the game is split into two brains. The server brain manages the behaviors of blocks and mobs, then sends the data to the client brain to handle the player's movement and render it onto your screen. To communicate with each other, the client and the server send each other small bits of data known as packets. Every little action, like placing a block, changing the weather, or registering a new potion effect, has its own packet. If we look at the code for that potion update packet, which tells the client to add an effect to a mob or a player, you can see right at the top that, as I suspected, the potency is stored using a signed 8-bit byte, which can only store whole number values from negative 128 to 127. Any input value larger than 127 gets wrapped around to negative 128, then continues counting up from there. This isn't a problem for many effects, since the client usually doesn't even need to know the effect level, as the server handles most of the work. But anything related to player movement is likely to experience issues from this. While this helps explain why the effect stops working only for players, it's not the full picture, as we still don't know why exactly the negative values are causing such odd behaviors. Searching through the code, we can see that levitation has just one primary behavior here in the entity travel function. This function is run on the server side to process the movement of mobs, and on the client side to process the player's movement. Our function begins by defining a floating point number variable. This represents the vertical velocity that will be applied to the entity. The relevant code starts fairly late into the movement process, so this variable is already initialized with a number representing the player's current vertical speed after collisions with blocks have already been processed. This means that the number will be 0 when the player is on the ground, a positive number if the player is moving up or jumping, or a negative number if the player is falling. To decide what changes to apply to this velocity, a conditional block is used, with the first condition checking if the levitation potion effect is active. If it is, the game will run this first block of code, skipping any further conditions, including this last condition that would normally apply a player's gravity. So, when levitation is active, it replaces the effects of gravity with the effects of levitation. The player's vertical speed is determined by this equation that factors in the level of levitation x and their current vertical speed y. The current speed is used to gradually accelerate the player into levitating and will eventually settle on a terminal speed. This is known in mathematics as a fixed point, a value that remains unchanged by transformation. It turns out that per the Banach fixed point theorem, we can actually solve this equation to get the fixed point speed for any potion level x. Let's rearrange our terms. Distribute 0.2, simplify, distribute 0.98, get the two instances of y on the same side, simplify, and finally divide by 0.216 on both sides. With this, we can plot how each amplification level affects the player's vertical speed. To get a better sense of the speed, I've multiplied each speed by 20 to get its value in blocks per second instead of blocks per tick. At x equals 0 is the only potion level obtainable in survival. It sends you upwards at a speed of a little under a block per second. At x equals 1, the speed increases by a little less than double, sending about 2 blocks per second upwards. Skipping all the way to the last intended effect, at x equals 127, we get rocketed into the air at a staggering 116 blocks per second. To view the unintended effects, we're going to have to expand our graph, as at potency 128, we wrap around to the negatives, which start pulling us down instead of up. As a reference, I've also added a line in blue showing the player's normal terminal velocity from gravity, which is 78 blocks per second downwards. Our negative line follows essentially the same trends, but in reverse. We start at potency 128 with nearly 116 blocks per second downwards, which is greatly exceeding the game's normal terminal velocity. You might expect the player to be unable to jump with gravity this high, but this isn't the case. The player is perfectly capable of jumping up blocks. It certainly looks a bit odd though, and if we look closely, we can see the player is actually being snapped up to the block. I couldn't identify the exact code responsible for this, but it's able to happen even without any levitation as long as you're falling fast enough. My guess would be the collision detection has some error correction that falls apart at higher speeds. But again, speculation. Potency 169, nice, is the first value to have a fixed point, or terminal velocity, less than gravity, although its initial burst of speed is still much greater than that of gravity's. At potency 179, the snapping behavior ceases, and the player loses the ability to jump up blocks. Going up all the way to potency 247, we've reached an initial speed close to gravity's. At 251, we're once again able to jump up blocks, and at 254, we're getting pulled down to the earth at less than a block per second, allowing us to jump up higher than 1 block. Finally, at potency 255, we've reached a terminal velocity of 0 blocks per second. If we go back to our original equation to check our work, we can see that when x is -1, it cancels out the addition by 1, then multiplies by 0. Like I mentioned earlier, a vertical speed of 0 is neither rising nor falling, which gives way to the zero gravity effect we observed. Except there's actually one last quirk here left to explain. If the player's speed on the ground is 0, like I said, and their speed with this levitation is also 0, then why does one allow me to jump but not the other? Every tick, the game checks if the player is directly above a block, and if they are assigned a speed of -0. The rest of the game's code then checks if the saved value of -0 is less than +0, which is true, so it decides the player is on the ground and thus allowed to jump. Meanwhile, levitation 255 produces a vertical speed of +0, which is not less than itself, +0, so the player is not allowed to jump. Originally, I planned to stop here, but if levitation is this broken, surely some other client-side potion effects are too. Surprisingly to me, swiftness and slowness actually both work as expected. The game reuses the attribute system for these effects, which uses floating point decimal numbers and thus doesn't face this issue. The next effects I checked were haste and conduit power, two effects that do the same thing. When applied individually, they appear to have no effect when used with potencies over 127, which is odd but not that exciting. But when combined, the player's digging speed slows to a crawl. This is caused by mob effect util getDigSpeed amplification, as it applies whichever effect's potency is greater. So, when used individually, the opposite's default value of 0 will be read out as the greater number, but when used together, it reads out a negative number. We can see its effect on the digging speed here in player getDestroy speed. The negative speed produces a negative mining progress, which will always be less than 100%, meaning you'll never be able to break any non-instant blocks. The only other broken effect I could find was Jump Boost, which, just like the levitation effect, mostly prevents you from jumping at potency 128 and gradually reduces its effects up to potency 255. The issue stems from the living entity jump from ground function, as the client receives a negative value from getAmplifier, thus reducing your jump. So, along with the previous video, these are all the potion overflow glitches I could find in Minecraft 1.16, and the end for now to this mini series on issues with potions in Minecraft. Please comment below if I missed anything, but otherwise I would appreciate your subscription, as next time I'll be taking a look into how a Minecraft world forgot its seed. Till next time, farewell.